Right, we're just going to do a test run of getting these balls molten and scraped off with that silicone wiper thing that we've got. And what we've got here is, and I'm hoping this will work. I have tried it before, but you never know. These are, I don't know whether you can see them or not, are tiny little, I think they're called magic dots, and they're tiny little silicone rubber dots with glue on both sides, and they're used in card making and you know, craft making sort of things. And what I'm going to do is I'm going to stick one on each corner of this BGA, and what I'm hoping this will achieve is to allow us to stick this down to the hot plate. Hopefully you can see there's one in each corner. This will allow us to put this on the hot plate without it moving around too much. Just going to put this right over the centre. That's perfect actually, because I've right, what I'm going to do, I'm going to put the process value thermocouple here, and it is just tucked underneath the, whether you can see this actually. Let me just reposition this camera. I've put the, so I've put the process value thermocouple, hopefully that's focused, and I've tucked it underneath the BGA. Okay, the other one here I'm going to try and put on the top of the BGA, just amongst the solder, and that one will be lifted out of the way when it's molten, and I can just scrape off the balls hopefully. That is the correct size. Probably strengthen it like I did before, just by holding a BGA against the silicone, and the idea is just to wipe that straight off like that. So I'm going to fire this up and it's going to be on 30 degrees first of all. We're at 13.6 on the on this top one, and 11 on the lower one. So yeah, all being if all goes to plan, we should be able to scrape these balls off in their molten state without risking any damage to the pads whatsoever. Now, I appreciate this particular scrap BGA would be going through you know, an additional heat cycle, and in fact Zetton's also will be going through an additional heat cycle, but the plan, you know, normally would be to remove the BGA from whatever board it's on and pop it straight onto this heat plate whilst it's still up to pretty much temperature. Yeah, that's the idea. So that heat cycle is removed from it, that these ones are going to be getting. Now whilst I'm on the subject of heat and things, I showed you that nozzle yesterday, and I was moaning how I didn't think that was a very good design where it's burnt in one place. Now Tony on the forum has told me that that is in fact because the element is not centrally placed in the hot air gun nozzle, so it's not really a fault of this nozzle. The heat, the hottest part, will be in the middle if your element is centrally aligned in the hot air gun itself. So yeah, it's not a fault of this nozzle, and it's really there isn't much to go wrong. It's only a circle, you know, round into a square with two sheets of mesh in there. So yeah, I'm not really particularly happy with my hot air gun, so I will probably strip that apart. I'd like to make the air supply tube longer, but on mine of course the wires run through that as well, so yeah, that may be a tricky one to do. But yeah, I would certainly look to realigning the element if possible, so the heat is in the middle of the hot air nozzle. Right, so at the moment we have well, we've set the set value as 30 degrees. Obviously we've got 43 on the top of the chip and 57 on the hot plate, so that's just hovering around that level now. So I'm going to knock this up to the next level for me, which is going to be 80. So that's now heating again. We're just really using this overshoot to our advantage at this stage. As we get nearer the reflow temperature, we'll be a bit more careful and make sure it does not overshoot our target temperature. I thought it'd be quite interesting to see the variation in temperatures between the hot plate value and the surface of the BGA. So yeah, hot plate temperature at the moment is what have we got, 69, and top of the BGA is 52. Again, the BGA is pretty much placed centrally. In fact, it's just left of centre of the ceramic element. So now we're up to 80 on the hot plate. Oh, actually it's going up to 84, 85. The heat's off, so we're just going to see what this overshoot is. 87. Big top of the BGA is up to 64. We're up to 90 on the hot plate. And 70 on the top of the BGA. So it looks like a 20 degree difference. Of course the BGA is only is not making direct contact on the hot plate because of those small silicon glue dots that we've put on there. Right, process value is on 100 now. Obviously there's no heat being supplied, it's actually been set to 80, so that's a 20 degree overshoot. And we're up to 82 on the BGA. That's just settling down now, so I'll knock it up to 120. Okay, that's heat on again. We have 102 process value, well, that's the hot plate, and 87 on the BGA. Beginning to get slightly closer figures between the two thermocouples. We've got 108 on the hot plate and 94 on the top of the BGA. we're up to 120, elements gone off. Just see what that overshoot is. $106 now on the element, 128 on the hot plate. It's 134 on the hot plate now and 115 on the BGA. Slowed down and stabilised, I think, so we will now crank that up again. I think we'll go for 150 this time. Something I'd forgotten to do, I was going to put some flux onto this BGA when it was cold. Obviously it's too late to do that now. Damn, that was something I wanted to do, but not to worry, it's too late, and this will be a test without it. And with the real one we'll probably put some BGA flux on there that might assist the wiping off process. Or of course it might not make any difference at all, I'm not sure. So hot plate value is now 147 climbing, 130 on the BGA. It's got a light heater power's gone off, we're up to 150, and yeah, 133 on the BGA. I think we'll just knock this up to the next level of 180. A little bit of smoke now coming off of I can't tell whether it's coming off the hot plate or the BGA or the element actually. But yeah, a little bit of smoke seems to be normal when you get up to this sort of temperature. Hot plate now 160 and BGA is 138. Let me just pan around here. 137, 138, 139. Down there we're on where are we? 160. So it's sort of keeping this 20 degrees difference. .170 hot plate and 153 BGA. Okay, that's 180 power off to the element and 160 on the BGA. I'm just going to let this overshoot and stabilise before we go up to the next level, because we're getting close to the temperature we need, certainly on the hot plate. Of course, this would be so much easier if we could just go out and buy a £20,000 Ursa station and a 200 quid hot plate. I'm sure Be nice if we could have that level of money, just go out and buy all the proper gear. But yeah, this keeps me entertained. We've got heat coming off of various bits now. I might have to actually fire up the fans. Just going to plug the PC case in, pop the fans on. Seems to be a bit of heat, a bit more heat today from that case. Alright, looks like that thermocouple moved slightly. I'm just tucking it back under. I've got 193, that's just jumped up a little bit. 197 on the BGA, so they're actually pretty close. That's obviously stabilised. I'm just going to knock this up to the same figure, 194. Both thermocouples showing 195 now. Heat's being applied at the moment. 195 BGA, 190 strangely on the hot plate. I think that's really just because I've moved that a little bit. But it's the top of the BGA temperature that we're really interested in. Actually, I'll get a pair of pliers ready to lift that heatsink off of the hot plate, because this will probably try and overshoot. You know, it'll, even with the element off, it will hold a lot of heat in there, might go up above our temperature if we're not careful. Well, the temperature's dropped down a fraction. I have a sneaky feeling that is in a direct response to me turning the fans on. Obviously there's some cooling of the case that the element sits in, and I think we just saw a very small drop in temperature on the top of the BGA, and in fact on the heatsink. The temperatures are now going back up again. We've got 189 on both thermocouples, 192 now. Our set value is 194, which they are now on. That's both, that's the current gone off to the heater. 194, 197. I think we'll just knock that up to 210. Okay, we've got 198 and 197. Heater back on. .202, top of the BGA. 200 hot plate. There's no heating on today in the workshop, so it is very cold out here. It's probably only 7 degrees perhaps in the workshop. So we now have 205 on the hot plate and 208 on the BGA. 210 now on the BGA. Quite stable now. Power's gone off. Just going to knock this up to 220. That's heat back on. 210 on the element on the BGA. 212 on the hot plate. So we are getting very near now. Yeah, I'm not sure those sticky tabs have done their job. I think we're up to temperature now. Hopefully you can see this. I'll try and do this side left-handed. Just wipe it off the silicone. Right, this side I'm going to have to do again. Just I'm just going to knock that off onto there. Power off to the element. Good job, this is a practice one. I'll just get my sucker. I've dropped it on the floor. Get around the front of the camera and I'll show you this. Hopefully. Where are we? Dear. Thought we had the macro on, but I'm not so sure. That has done a pretty good job. Just wondering if the macro is on actually today. It is, yeah, there we go. Oh, come on, focus. Yeah, you can see the pads are very clean. There might be one or two that just need the lightest of touches with wick, but possibly not. I'll have to look at it under the mantis after this is cooled down and I've cleaned it up with a bit of flux remover. But yeah, I think that's a pretty good result. It's a shame the stickers didn't work. It looks like they've been completely melted. That's not what happened when I tried this in the oven, but yeah, it's not a bad effort. Anyway, yeah, I thought I'd show you that. Dropped it again. I'll catch you later.